Okay, so this is an example of the Java collections code, you know, the code that Java provides for us that we can use. So we can import, you can actually do an import Java util.star, and you'll pick up all of these things, but I was just kind of spelling it out so we know which ones we're actually using, which packages we're using. So I'm using the array list, a list, this class called iterator, which, yeah, I might as well go over that again. And then collections, where we can use algorithms on these structures. So let me actually first go over the iterator. So you know how when you have an array, you can go, you can use an index, you can use an integer, I, and go through the array, right? You could just say for I equals 0 to n minus 1, and then whatever I is equal to, you look at that box. So for a linked list, we know if we want to go through a linked list, we would have to create something like that current pointer, and then the way we go to the next item is to say currents next, current equals currents next. So it might make sense for us to try to take the idea that any structure that is sequential, so for example a heap is not sequential, but a linked list is, and an array is, and a doubly linked list is, anything that is sequential, the concept of starting at the beginning and going to the next one and the next one and the next one until you get to the end makes sense for that structure. So depending on how you start at the beginning and then go to the next one and the next one, next one until you reach the end, could be different from structure to structure. But the idea is still the same. You start at the beginning and then you go to the next one and the next one and the next one. So what they wanted to do was to have a pattern that any sequential structure, anything that you can iterate through, we would want to make a type called iterator for that structure. We want to have an iterator for a list and an iterator for an integer. So then we would add methods to it like next, and if you call the next method, it returns the field that's next for you. So for example, if you wanted to, this might seem like overkill, but maybe for a class like an array, we would want to do something like this. We would want to say something like, this might seem like pointless because you would just use an integer and then say +1 to get to the next one. But we could have a class called like an integer, an array iterator. And then in the class we would have a private integer I, like we always do. We always have an integer I. And then we would start having public methods like public next. And what would the next method do? It would, for an array that uses an integer to iterate through, we would just take the integer and add 1 to it. So it would be I ++. It would be a one-line method that just adds 1 to the current value. And there would be other methods like previous and whatever makes sense for an integer. Now what would be the point of having this new class called an array iterator? So now if you're going to use an array, instead of saying int I and letting I walk through it, we now declare something as an array iterator. Now we get this function called next, which does the work for us. Now obviously if this was a list iterator, the next function would change. What would the next function be? The next function would say
Currents assigned current next.
right, if the thing, so the thing that we're using to iterate through would end up in a list, would end up being something like node, a node reference called current. And then the next function would be current equals, well, the next field would be part of the node, so it would just be next, right? Could say current equals current is next, but it would just be next. The next field. So the idea is, we would make the iterators for anything that is sequential, that you could iterate through, we'd make all the functions have the same names, and their functions would be like previous and next, you know, it's the standard function you would do with an iterator. But then we don't have to worry about what's going on the inside, we just need to remember the function's names, like next and previous, and just hope someone else wrote it for us. And then if you ever come up with your own data structure that happens to be sequential, you could just follow this pattern and come up with a corresponding iterator class. But that's really what they want to do. So now if you ever wanted to dump all the elements from a linked list into an array, you would just go from one iterator to another. You wouldn't have to worry about coding up the iterator. You can just count on it to, be, you use the iterator, it starts at the beginning and walks through the next one, and you don't even have to worry how the next one is, because hopefully the person who coded up the data structure got that part right. So, for example, I wanted to focus just down here. What I'm basically going to do in this case, in this code, it's one example, it fits all on the screen, so it's small enough. I just took a few names from students in the class, and I'm creating an array list. That's the type that Java gave us that name. This ends up operating like a list, though, it's not an array. And then what I'm doing is I'm going to create a list, and I'm going to add some people to the list, I'm going to play around with the list, and then every time I play around with it, I want to print it out again. So I decided to make a separate print list function. So you pass in a list of type list, and then I declared what is now going to be a list iterator. So the direct declaration goes like this. It's an iterator of strings. So it's something that will walk through a list. And it'll go from list iterator, which is the beginning of it, and then as long as it has a next. So there's a method called hasNext for anything that's sequential. They all have the same method. And this ends up being an interface method. So you remember what in Java, when you say that something implements an interface, it means you provided a method for all of these functions. So hasNext is a Boolean that will say if the next field is set to something other than null, it will return true. So as long as this has a next thing, we will then, I'll say string equals the, I call the iterator, I call it IT instead of the traditional I for index for an array. So I take the next one, and this actually makes, this next function not only returns the value, but it also makes the iterator go to the next one. So 2 steps in one. So this is basically a standard for loop. Instead of, we're used to seeing for int I equals 0, comma, I less than max, then semicolon I plus plus. That's what ends up keeps happening. I'm actually not doing the I plus plus because it'll be taken care of by the next function. So I'm just going and getting the next thing and then printing out the next thing with a semicolon, then get the next one. I keep doing that until there's no more next. So this right here is the code that iterates through a list. So now what this code is doing is it's saying, it's creating a list, it's adding Tom, then it's adding Jesse, then it's adding Deep, and then it's adding Colton. And then I print out the list. So what would you expect it to do? So the print list starts with the iterator at the beginning and keeps printing until it hits the end. So it should print out Tom, Jesse, Deep, Colton, right? Then if we look up, you can look up on Google of all the functions that comes with a list. One of the functions was we can say set node number 2. Now the way lists work is they do start like arrays with 0. So I'm changing node number 2 to be Sandy. So what does that do? I'm not inserting, I'm setting the value. It will change. Tom is going to be 0, Jesse's going to be 1, Deep is going to be 2, Colin's going to be 3. This is going to change node number 2 to Sandy. So I can then print out the list again, and it should print out Tom, Jesse, Sandeep, and Colton. Then there's a method called sort, which happens to use, I was reading up on it, happens to use not a perfect quicksort, but it does a quicksort that uses a heap to pick out a good pivot, so you don't get into that bad, worst case scenario where you pick a bad pivot. So they ended up using some kind of hybrid of quicksort and heap sort. That's what Java ended up using in their collections algorithm when you run it on a list. And if the list is really big, it'll dump the list into an array and sort it out of an array and then dump it back into the list. But anyway, how they do it is not our problem. They just did it, and hopefully they picked a fast sorting algorithm. So, and actually, I would actually hope that in the case where the count is 4, they wouldn't bother creating there's a lot of overhead in running like a quick sort. You would hope they'd say, well, since it's only 4, I'll do a quick bubble sort or something real quick, not do all the overhead. But anyway, we're counting on the creators of this algorithm to do it quickly, so I sort it and then I print out the list again. That should come out. Now it just so happens strings, the compiler will know what it means to be less than the other. It would just go by alphabetical order. If, for example, instead of me pushing strings onto this list, if I made a class like a first name and a last name and a social security number and a date of birth, and then I just said sort these, this algorithm would want to know sort by what? By last name, by social security number, what do you want me to sort by? And then we would have to add something, we would have to explain what, we'd have to override a function called equals and override a less than function to explain what does it mean for one person to be less than another person, or one person to be equals to another person. So we could say it could be based on last name or age or social security number, but we would have to tell the compiler how to sort by what. But right now we don't have to do that because we're just strings and it'll do it by alphabetical order. So I can call sort and then print them out. So now what should happen is it should say, so Sandeep replaced Deep. So, and now it's been sorted. It should go Colton, Jesse, Sandeep, Tom. And then I have another routine called shuffle, which takes anything in the list and scrambles them into any order you want. And then it should be, I don't know what to expect, but it should be the 4 names in some random order. Okay, then another thing I do, just to show, like, once we start to use structures that they provided for us, it's very easy to pop stuff out of one structure and throw it into another structure. So what I did here, maybe I should put a space in here, I just want to try to get it all on one page. I created an array, not the data structures that they give us, but the standard array. I made an object array, so I called it OA for object array. And I said it's equal to the list, and there's a function called toArray. So the function toArray takes your entire list, your entire linked list, and converts it into an array. And then just copies the array over to this array of objects. And then I print out how many objects are in my array of objects. Hopefully that should be 4. And then I say the second element is, I take the array and I take index number 1. Now I can actually, because it's an array, I can actually, instead of using an iterator, the secret way of walking through the object, we can actually just print out number 1. So the first one is 0, the second one is 1. So I'm saying the second element is, that should be, well, I don't know what it'll be. It'll be however it was left off after the shuffle. You know what, I should flip these two, because then the second one should be whoever comes out second in sorted order. But anyway, whatever comes out second would come out here. And I ended up printing the list again. What's the point of that? Maybe I'll get rid of that and I'll flip these 2 lines. So that way we'll do the shuffle first, that'll be the random order, and then I'll do the sort, and then we'll know exactly what the second one is. Yeah?
With the, this is the nomenclature that's used in the for loop at the bottom for the iterator.
Right.
Is that standard? You have the Boolean after the, you always have a Boolean or some test there like that? It has next, is what I'm looking
Well,
at.
yeah, so
All within that for statement.
Yeah, actually, the way for loops always work, there were 3 statements on top. The first statement is an initializing one, like, normally we used to say int I equals 0, something like that. The next one is a condition that's always true or false, like I is less than max, or, in other words, keep the loop going if this is true. And then the last one was usually like I equals I plus 1,
Right.
like to make it go to the next step. So you could have, at any point, left out the third one, as long as you did I equals I plus 1 somewhere in the for loop. You didn't have to put it here, but this was basically a line that executed at the end of the for loop.
Okay.
Whatever you put as in the third spot here would get executed after the loop had finished. So if you think about it, yeah, that's actually a good point. You could take the I in a regular for loop like we used to, the I plus plus, we could remove that and put it at the bottom of the brackets, and it still works the same. So in this case, it just so happens that the next function, which returns the next field, it also increments the iterator for you. So we don't have to, normally you might think something like iterator equals iterator plus 1 would be here.
I wasn't sure if there was always like a Boolean test up there when you use an iterator within the for.
Well, a for loop is always, the first thing is the initializing statement.
I see what you're.
The second one's a Boolean, and the third one is a place where you can increment, make some kind of a change, so you don't loop forever. But it turns out, in the body of the loop, the thing we want to do is being done. So this is a pretty common, like if you look up, if you go on Google and you look up iterating through a Java list, you'll see this. This is like 95% of the time it's written that way.
It's like a while test.
Yeah, and you could even do while, what would we do in while? While has next. For the while loops, it'll always be has next too. As long as it has next, keep going. And then as long as you keep calling the next function, you will not go into an infinite loop. Okay, so yeah, let me make those coding changes. So what did I say I was going to do? One of these print lists, I think it's just kind of a leftover one. I'll take this one out. And then I wanted to reverse the sort and the shuffle. And this one back. So I'm going to shuffle them. So first I'll print them. Then I'm doing a replacement. I'm replacing Sandeep in slot number 2, which looks like it's going to, slot number 2, it goes 0, 1, 2, and 3. So slot number 2, it'll replace, Sandeep will replace Deep. I'll print out the list again. Then I'll shuffle them, they'll come out in random order, so who knows what to expect. And then I'll sort them. That one we can expect it to be Carlton, Jesse, Sandeep, and Tom. And then when I go to print out the item number 1, it should be the second person, not 0, but 1. It should be Jesse. Okay, so by reversing the order, it got a little more predictable. So let's see, C2, CS, E2 corrections. And then Java, C, what's this thing called? Java C, list, to, array, Java, right? And we get that 1, okay. And then we want to say Java and the name. So we got Tom, Jesse, Deep, and Carlton. Then we did the replace, where we replaced Sandeep, got written on top of Deep, so now it's Tom, Jesse, Sandeep, and Carlton. Then we did a random order, which happened to shuffle. Wait a minute. Did I save it? Maybe I didn't. Oh, sorry. Maybe I didn't save it. Okay, yeah, I wanted the fourth one to be the shuffled one, because it's coming out the third one. Okay, so yeah, so here's Here's the original 4, here's Sandy replacing Deep. Here's the array after it's been shuffled, so it is in a different order and it's not sorted, it's just some random order. And then the 4th one is the array in sorted order. And
Jesse
then,
gets printed.
then what do we do after that?
Jesse gets printed.
Was that?
Jesse gets printed.
Yeah, and then we said the second element is Jesse, so, but that was, after we took the list right here, called the toArray function, which Java provided for us. That takes a list and converts it into an array, and then put that into an array of type object, not of type string. I was just doing this just to kind of play around. And then I said the array has the length came out, so the length should be 4. The length is 4. And then I said, now I have an array of objects, but what I'm doing is I'm saying, the second object is, I take the array of objects, element number 1, so 0 is the first one, 1 is the second one. I can cast it to a string so we can see what it actually is, and it said it's Jesse. And then I decided to make an array of strings, just to show it could be objects or strings. And I have an array of strings, and then I printed out the length of the array of strings, and that should also be a 4, which is this one, this 4. Okay, so it turns out that, among other things, a list has functions. Obviously, we want a function like add. Now, it looks like we don't have add front and add back, it's just add, and apparently it's adding it to the back, right? And a list is a one-way list, so if we had a two-way list, then we'd need functions like add to the front and add to the back. And we just look up on Google, we don't even need to buy books anymore, and just find out what the names of the functions are for that type of data structure. So, and then whatever you think a structure should have as functions, like toArray, I wouldn't even guess it has that. I just happen to know it because I've seen it before. But if you have a linked list, it might be pretty common you'd want to convert it into an array to do something like sorting, which would be very quick on an array and very painful on a linked list. So you might have linked lists that from time to time you need to convert them over to an array to do something and then convert them back to a linked list.
Does it have the inverse, going from an array to a linked list? Just out of curiosity.
That would, well, yeah, let's just think that one through, because what this ends up being, you don't want to memorize all the functions of all the data structures.
Right.
You just want to know what the data structures do, and then think what would make sense to have. And so, in order to have an array convert to a linked list, the class array would have to have a function called something like toList. So before I say no, I'll check it. I mean, it would have to have that name, right? toList. So if we go to Google.
toList or linked list or something. toList makes sense.
Java array toList. Well, so obviously a lot of people write about it on Google. Array to array list. So, how to convert a string array to an array list. So this is a little. It looks like
Array as list, my array.
arrays.asList, and then you give it the array. So it's not a function of, it's not a method on the array class. It's a, what is arrays? There's a utility called arrays. See this thing, Java, you include Java util arrays, and it has a method called asList. And you pass in an array. So the answer is it can be done. So you know what, before I looked this up, I would have answered, my answer would have been probably no, because, and the reason, my only thinking is, arrays were created before the collections were added. Like in Java, the first day Java came out, it had arrays, right? You can't have a programming language without arrays. They didn't think ahead then that there would be collections that you'd want to convert arrays into linked lists. They weren't even around then. So if they do exist, they were added later. And I would almost think it wouldn't be worth it to add because old code may not work or old code might take up more space and people might not want arrays to have this. So the only way it could exist would be if somebody came up with a new set of functions that takes an array and converts it into a linked list. So that, yeah, but then the thing is, why give an answer? You know, look it up on Google. If it's there, someone wrote about it. If it doesn't exist, you'll probably find someone saying, can this be done? And someone says, no, it can't. But you could, and you know, just what I'm saying is this: you don't want to memorize every method of every data structure. You just want to know what the data structures do, and then ask yourself, what am I trying to do today? Which data structure would work? And then say, I hope they have a method that does this. It makes sense that they should have one, and then just go find it. And even like, there's no, like, one of the reasons I said for this class I don't have a textbook is because if somebody wrote a textbook 5 years ago, there might be new methods that aren't even mentioned in the book. So Google is the world's live textbook, right? So just look it up there. If somebody wrote about it, you'll find it. So in this case, we just looked at it and found it. So there is a way to do it. Now, what would be a real world reason if you have an array, you'd want to turn it into a list?
If you were looking at
Yeah.
if you were looking at existing code that was written and you had to convert it, it was old code or something.
Right.
That's what was going through my mind.
Yeah, or even if for some reason you had a linked list and all of a sudden you're going to be doing a lot of inserting into the middle of it. Like, let's say your application, for whatever reason, you have an array, a really big array of stuff, and once in a while, once a month, you insert something. So you'll go through the pain of moving all the nodes over one to do an insert. But now all of a sudden, something's changed with your business, and you're going to be inserting a lot into this.
Right.
What you might want to do is convert it to a list, do your inserts, and then convert it back. You know, that might be some need for it.
I just a while ago.
Yeah, but yeah, obviously it can be done, and it would make, if there was no method that did this, you could write your own, right? You would have an iterator for a list, you'd create an iterator for the array, and then just start them at the beginning and increment both and copy one over, increment both. It would just be a for loop. I mean, you could do it yourself. What's going on in this as list, this is a method somewhere in Java utils arrays. So it's some method in there. We could almost guess what it's doing, right? It's starting both things at the beginning, copying one over, incrementing the 2 pointers, copying, and keep doing it until the list runs out. And it's not that hard, it's just somebody else wrote it. If it didn't exist, you could write it yourself pretty quickly, but it just so happens it's common enough that they decided to add it to the language. Okay, so then another example of using these Java collections was a piece of code. A hash map demo. Okay, so what's going on here, I should have used other students' names, but I'm using the same ones. So if you remember what we talked about what hashing was, hashing is where you have a key value and another value. So they come as a pair. Key value has to be unique and the other value doesn't have to be unique. So in this case, I'm saying whatever the first one is the key, and whatever the second one is what value you're putting in. So let's say these were people and their, I don't know, bank account balance or something like that. I was just picking random numbers. So we're using now what's called a data structure called a hash map. And instead of going Java util.hashmap and bringing in everything I want, I said Java util star, which actually brings in everything, but might take a little bit longer to compile, but at least this way I don't have to keep typing in everything I need. So what I'm doing now is I'm making a hash map, and I'm mapping strings to doubles. So what that means is like for every, I have to put in unique strings. I can't put in the same string twice because it'll tell me it's not allowed, it's already in the structure. And then for each of those things I can put some values. So now if I wanted to find something, I could search for, say, Jesse, and it'll tell me 22 is the value associated with Jesse. Yeah.
Why did you use a double? I saw that on the test, in
Um,
fact, you use a double.
It-
As opposed, I
As
cast
oppo-
it to an int before I started to use it, I thought it was a trick.
There was a double on the test?
What you gave to start with, I remember there was a double somewhere.
Okay, it doesn't have to be a double, it could be,
an int.
this could have been an integer.
Okay, I didn't know if there was a particular reason, that's why I.
No, okay. So, but the other thing is, do you remember what a double with a capital D is, or an integer with
Yeah,
a?
it's an object.
Yeah, so that was a Java concept, was that, like an int, int, all little letters, that is a piece of storage with a value in it, whereas integer, capital I-N-T-E-G-E-R, is a reference to an integer object. So the way the hashes work, they only take references. So you couldn't use a double or an int or a float, you have to use a reference to a double. So that's what this capital D is. So capital D is a reference to a double, and I'm loading it with the number 11. I'm putting that into its constructor. So I'm saying construct me a double field with the value 11 and return the reference to it. So that's just a little reminder of something from Java, first semester of Java. Okay, so what I'm doing is now I'm creating a structure. So it's a two-dimensional structure. It has a key and then a value associated with the key. So what ends up happening is there's a hash function that is provided by the compiler, which will take this string Carlton and convert it into some number. And I think the default, they don't require that they stay with the same default, they can change it from year to year in Java, but they basically, I think they take the memory, the address of the memory location where it's at and convert that into a number, and then that's the number that it gets assigned to. So for example, Carlton might get converted into a number like, 16, some big number, an integer number, and then it gets put into an array at that location. So then, the number 11 gets stored at whatever Carlton got converted into when Carlton ran through the hash function. So I'm putting 4 numbers associated with these 4 keys into a hash map. Then what I'm doing is I'm taking the hash map and I'm copying it over to a set, and now I'm creating an iterator for a set. See now at first the iterator thing was a little annoying, like why are we adding this extra declare, but now we can just whatever data structure we have, there's an iterator that goes with it. If it's a data structure that you can sequentially go through. So now I'm creating a set and I'm just creating an iterator to go through it, and then I'm saying while I has a next. So I did the while version here in the 4 in the last example. And then I'm copying these things into a map structure. So really all I'm doing, there's no real point to what I'm doing here. I'm just taking stuff from a hash map, putting it into a set, and then copying it from a set into a map. And then just printing out the stuff that's in it. So now what I can do is I can say, once I have the structure set up, I could do something like, I could take my hash map, I pass in Carlton, that's the thing I'm searching for. Carlton runs through a function that turns into a big number. It runs out to the hash table and at the slot of that big number and returns whatever value is there. So this is double value returns a double, that's one of the functions that comes with the hash map. And it returns the value 11, and then I'm going to add 1,000 to that, so it should be 1,011. And I put that into my hash map. Now, you might think there'd be a second entry, a Carlton 11 and a Carlton 1011. But the first value are keys, meaning there's no duplicates. So if I go to write onto Carlton, it's going to change the number from 11 to 1011. And then I print out the new balance by doing a get. So I know that, so the point of a hash map, we're not gonna be able to see the value in this because there's only 4 of them. But the idea is that we can go and search for stuff, we can grab stuff very, very quickly. So what's involved in going and getting, like, let's say, for example, this was a linked list. If we went looking for Carlton, we'd have to go to the beginning of the linked list and search through each link until we matched a Carlton. Because it's a hash map, we read Carlton, we run it through a function that converts that to some huge number. Then we look into the huge array the memory that we ate up to do this, and we immediately go to that spot and we'll find Carlton. If it turns out that Jesse mapped to the same slot that Carlton mapped to, then I don't know what they do behind the scenes, but they probably build a linked list and have Carlton and Jesse start coming off of a linked list. It is possible that the hash function, which is called hash code, that one gets called implicitly. It is possible that you could pass in 2 different strings and it would return the same number. Our hope is that that doesn't happen, or it doesn't happen too often, because that means we have to then start walking through a linked list. We'd like to be able to just have a number return, go to that spot in the array and get the value immediately. So what this code is basically doing is it's loading 4 different, let's say, account balances for 4 different unique people. So if I added a 5th line here that said Carlton with a different number, I don't think it would write it on top of it. I think it would be a compiler error. Because you can do a put for something that already exists. That means you're replacing the value. But I don't think, no, I guess no, it would write it on top, because these are puts too. So I could put it here, it'll just write up with the value on top of it. Okay, so yeah, let me compile this code and run it, just to make sure it runs safe. And, so let's see. So this one is called hash map demo. So it says Carlton 11.0, that's right, yeah, because floats are, I'm sorry, doubles are, have a fraction part, so 11.0. Tom is 44.0. Jesse's 22, so the numbers are right, but they're not in order, and I guess that's okay. Because I'm iterating through them, but hash maps don't guarantee that they're in order. They're basically, so,
Is it looking at the values, when it iterates through, is it looking at the values that were, that come out of the hashing function? In other words, Carlton was converted to a number, Deep was converted to a number. Is it looking at those and putting it in those order by any chance?
no, I mean, what it's basically doing is, what it's basically doing is, when you're creating a hash, again, we'll just go, the hash goes like this. The way a hash would work is something like this. Let's say we have a set of numbers. I'm sorry, a set of items to put into a hash. So let's say we had 1,000 items. We might want to create an array of, the number would have to, in order for a hash to work successfully, we want the number to go from, let's say, 0 to 1,000,000. If we're hashing, say, 1,000 things, we kind of want that ratio, we want it to be a lot bigger. Then, when we put an item into the structure, we want to run a function, we want to take the item, somehow run a function on it, that will return a number between 0 and 1,000,000. Well, let's say 1 and 1,000,000 minus 1. It'll return a number between you know, a million minus one, some kind of randomness to it. Because what we don't want is other items to keep coming out with the same number. So then we find a spot and we say, okay, we're gonna put Carlton right here. And this would end up being, now how this is done is, however Java decided to do it, my mind thinks of it as a linked list, but I'd end up saying Carlton 11. Now, if we want to go and let's say somewhere else, Jesse got put over here. Let's say this is also a linked list. And the reason why I'm making a linked list, I'll give an example in a second. This would be Jesse 22. Now, this structure we have, as long as this array is, it helps a lot if the array is much, much bigger than the number of items, much, much bigger than n. If we now want to look up Carlton, how can we do it? We take the phrase Carlton, run it through this function, and it returns this number. Let's say this number was 65,246, some crazy high number. If we can have a function that will convert Carlton into 65,246 very quickly, not some n squared algorithm, but hopefully something like a few steps, it could do that, then we would find Carlton very quickly. Now suppose hypothetically, Tom ran through the hash function and gave the same exact number that Carlton gave. It would be kind of like lightning hit, you know, it would be rare. Assuming your hash function sprays the things out, it would be rare, but it's possible. So what do we do if we have the same number? I would create a linked list. I mean, obviously we're going to come to this spot. So sometimes they'll say take the next spot that's available, but there could be someone else in that spot, so then you have to go 2 spots away. Either way, you're going to hit this spot and then have to check something and maybe something else and something else. But in order for hashing to work well, you want the number n, you want the size of this array to be a lot larger than n. If it was half of n, then every slot would on average be at least 2 things. Some of them might be very large. And the other thing you have to be careful of is you don't want your hash function to keep sending you to the same spot. Then the whole exercise is a waste of time, you end up with a linked list. So what we're doing in this code is we are hashing the pair Jesse and the number 22, and then storing it somewhere, and the goal is to go and retrieve it very quickly. So then when we go to update the value for Carlton, we had to do a get of Carlton, and hopefully the get works very quickly. It should be order 1 if this linked list is not that long. If this linked list is 1 or 2 links, it's order 1. If this linked list starts growing, then there's something wrong in the way we're hashing. So that's really what this code is doing. So it's basically saying that we are, what the code is basically doing is I declared a hash map structure, which is going to make that really big array, and then I'm putting items in it, and then I'm going through, then I went through the items to print them out. Oh yeah, so the thing I was saying was, why did it not come out in the order in which I put them in? Why did it just come out in a random order? Which is, did it come out in a random order? This order. This came out in a random order. The reason is, they're being thrown into this structure in random spots based on the hash code, and now I'm saying dump the whole thing. And it looks like it's just going through it sequentially, but there's no guarantee that the thing I put in first goes near the beginning of the array. If the hash function is random, it could end up anywhere. So it's just, it's a little code snippet that just gets across the idea of what a hash is. You wouldn't use a hash if you're only putting 4 things away. You could put it in a linked list and you'll find the stuff quickly. It's when you start storing a lot of stuff and you need to access them really quickly. So if you're, like if it's Facebook and you're logging in and you want to find, let's say you have 50 friends in Facebook and they want to give you all your friends the moment you log in, it might be good if they hashed all your friends. then you could gather them up quickly. So it's when n becomes, again, hashing is used when is a very large number and you plan to do a lot of searching. If you're not gonna do a lot of searching, you don't need hashes. Hashes are for quick retrieval for things you're searching for. It only has value when n is very large, and be prepared to eat up a lot of space, because they're gonna make an array 10, 100 times bigger than whatever your n is in order to do this. And you also have to make sure your hash function doesn't keep giving the same value, doesn't repeatedly give the same value, because you want to spray out your values, the nodes on your hash array. Okay.